Have you ever experienced something so strange, so inexplicable that it made you question the very fabric of reality? Perhaps a sudden, uncanny sense of déjà vu, or a moment where time seemed to slow down or even stop altogether. These fleeting glitches in our perceived reality, often dismissed as tricks of the mind, have fueled centuries of philosophical debate and, more recently, a compelling scientific theory known as the simulation hypothesis. This theory, while seemingly rooted in science fiction, proposes a profoundly unsettling possibility that our universe and everything in it is not real, but rather an incredibly complex computer simulation. Imagine a world indistinguishable from our own, governed by meticulously crafted lines of code, where every atom, every star, and every thought exists only within the digital confines of a supercomputer. While this may sound like something straight out of the Matrix, the simulation hypothesis is gaining traction among some of the world's leading scientists and philosophers who believe that we may be living in a meticulously crafted illusion. What was once relegated to the realm of late-night philosophical debates is now a serious area of scientific inquiry, forcing us to confront the most fundamental question of all: what is real? As we delve deeper into the simulation hypothesis, we will explore the scientific advancements and philosophical arguments that have brought this mind-bending theory to the forefront of modern thought. Prepare to question everything you thought you knew about reality as we embark on a journey into the very heart of existence itself. The simulation hypothesis, in its simplest form, proposes that what we perceive as reality is nothing more than a sophisticated computer simulation designed by an advanced civilization capable of manipulating information on a cosmic scale. Imagine a world where every detail, from the smallest atom to the vast expanse of the universe, is meticulously programmed. This isn't merely the stuff of science fiction, it's a concept that has been rigorously explored by philosophers and scientists alike, including myself. The idea challenges our understanding of reality and pushes the boundaries of what we consider possible. In 2003, I published a paper titled, "Are You Living in a Computer Simulation?" which laid out a compelling argument for the simulation hypothesis. This paper sparked widespread interest and debate within the academic community. My argument rests on the premise that future civilizations will likely possess immense computational power, capable of creating simulations indistinguishable from reality. These simulations could be so advanced that the beings within them would have no idea they were part of a virtual world. Given enough time and resources, it stands to reason that these civilizations would create countless simulations, perhaps as a form of historical recreation, scientific exploration, or even entertainment. The possibilities are endless, and the motivations behind creating such simulations could be as varied as the civilizations themselves. If we accept the possibility of numerous simulated universes existing alongside our own, the question then becomes, how likely is it that we are living in the original, real universe, as opposed to one of the many simulations? This question forces us to confront the very nature of our existence. The sheer number of potential simulations when compared to the single real universe makes it statistically more probable that we are, in fact, simulated beings. The odds are overwhelmingly in favor of us being part of a simulation, rather than the original reality. This line of reasoning has sparked countless debates and discussions, challenging our most fundamental assumptions about the nature of reality. Scholars, scientists, and thinkers from various fields have weighed in, each bringing their unique perspectives to the table. Is it possible that everything we experience, from the taste of chocolate to the feeling of love, is nothing more than a series of carefully orchestrated algorithms? Could our emotions, thoughts, and sensations be pre-programmed responses within a vast digital framework? The implications of the simulation hypothesis are profound, forcing us to reconsider our place in the cosmos and the very meaning of existence itself. It challenges us to think beyond the physical and to question the true nature of our reality. The rapid pace of technological advancement, particularly in the fields of computing and artificial intelligence, lends further credence to the simulation hypothesis. This hypothesis suggests that our reality might be an artificial construct, a sophisticated simulation created by an advanced civilization. As we delve deeper into the realms of technology, this idea becomes less far-fetched and more plausible. When we consider the exponential growth in processing power, data storage, and virtual reality technology, it's not difficult to imagine a future where creating realistic simulations is not only possible, but commonplace. The advancements in these areas are staggering, with each passing year bringing us closer to the ability to replicate the intricacies of the real world in a digital format. Consider the video games of today, with their immersive environments, lifelike characters, and complex physics engines. These games are not just entertainment, they are a testament to how far we've come in simulating reality. The level of detail and realism in modern video games is a clear indicator of our potential to create even more sophisticated simulations in the future. What was once a pixelated pastime has evolved into a multi-billion-dollar industry pushing the boundaries of realism. Game developers are constantly innovating, striving to create experiences that are indistinguishable from real life. This relentless pursuit of realism in gaming is a microcosm of our broader technological ambitions. As technology continues to advance, the line between the virtual and the real will become increasingly blurred, making it ever more difficult to distinguish between a simulated experience and genuine reality. Augmented and mixed reality technologies are already beginning to merge the digital and physical worlds, creating hybrid experiences that challenge our perceptions of what is real. The development of artificial intelligence, or AI, further fuels the fire of the simulation hypothesis. AI is not just about creating smart machines, it's about understanding and replicating the processes of human thought. As we make strides in this field, the possibility of creating conscious, self-aware entities within a simulation becomes more conceivable. We are on the cusp of creating machines capable of independent thought, learning, and problem-solving. These AI systems are becoming increasingly sophisticated, capable of performing tasks that were once thought to be the exclusive domain of humans. The implications of this are profound, as it suggests that we could one day create digital beings with their own sense of self and purpose. As AI becomes more sophisticated, it's not inconceivable that these artificial minds could one day surpass human intelligence, potentially designing and inhabiting their own simulated realities. This raises intriguing questions about the nature of consciousness and the potential for digital life forms to experience their own version of reality. The advancements in quantum computing represent another significant leap towards simulated realities. Quantum computers operate on principles that are fundamentally different from classical computers, allowing them to solve problems that were previously thought to be unsolvable. Quantum computers leverage the bizarre and counterintuitive laws of quantum mechanics to perform calculations at speeds unimaginable with classical computers. This exponential increase in computational power could be the key to unlocking the ability to simulate entire universes in exquisite detail. This exponential increase in computational power could be the key to unlocking the ability to simulate entire universes in exquisite detail. Imagine a computer so powerful that it could recreate the complexities of our own universe, down to the smallest particle. While we may be decades or even centuries away from achieving such technological feats, the trajectory is clear. We are rapidly approaching a future where the creation of simulated realities is not a matter of if, but when. The advancements we are making today are laying the groundwork for a future where the boundaries between the real and the virtual are indistinguishable. And as we hurtle towards this technological singularity, the question of whether we ourselves are already inhabiting a simulation becomes even more pertinent. The more we learn about the nature of reality and the capabilities of our technology, the more plausible the simulation hypothesis becomes. Are we the creators of our own simulated worlds, or are we merely inhabitants of a simulation created by a higher intelligence? The answer to this question may redefine our understanding of existence itself. Perhaps the most intriguing evidence supporting the simulation hypothesis lies not in the realm of computer science, but in the strange and often paradoxical world of quantum mechanics. This branch of physics, which governs the behavior of matter at the atomic and subatomic levels, is filled with phenomena that seem to defy common sense and challenge our very notion of reality. Quantum mechanics, the branch of physics that governs the behavior of matter at the atomic and subatomic levels, is rife with phenomena that seem to defy common sense and challenge our very notion of reality. One such phenomenon is quantum superposition, where particles can exist in multiple states simultaneously until observed. One such phenomenon is quantum superposition, where particles can exist in multiple states simultaneously until observed. This suggests that the act of observation somehow influences the state of reality, a concept that has profound implications for the simulation hypothesis. This suggests that the act of observation somehow influences the state of reality, a concept that has profound implications for the simulation hypothesis. Could it be that our simulated universe only renders the details of our reality when we directly observe them, conserving processing power by leaving the rest as a wave of quantum probabilities? Could it be that our simulated universe only renders the details of our reality when we directly observe them, conserving processing power by leaving the rest as a wave of quantum probabilities? Another puzzling aspect of quantum mechanics is quantum entanglement, where two particles become linked even when separated by vast distances. Another puzzling aspect of quantum mechanics is quantum entanglement, where two particles become linked even when separated by vast distances. Any change to one particle instantaneously affects the other, regardless of the distance between them. Any change to one particle instantaneously affects the other, regardless of the distance between them. This seemingly impossible connection, dubbed spooky action at a distance by Albert Einstein, hints at a deeper underlying reality that transcends our classical understanding of space and time. This seemingly impossible connection, dubbed spooky action at a distance by Albert Einstein, hints at a deeper underlying reality that transcends our classical understanding of space and time. These quantum quirks, while still not fully understood, offer tantalizing clues that our reality may not be as straightforward as it appears. These quantum quirks, while still not fully understood, offer tantalizing clues that our reality may not be as straightforward as it appears. The bizarre and counterintuitive nature of the quantum realm aligns surprisingly well with the concept of a simulated universe, where the laws of physics could be manipulated or even rewritten by the programmers behind the simulation. The bizarre and counterintuitive nature of the quantum realm aligns surprisingly well with the concept of a simulated universe, where the laws of physics could be manipulated or even rewritten by the programmers behind the simulation. Could it be that these quantum anomalies are in fact glitches in the matrix, subtle hints that we are living within a carefully constructed digital reality? Could it be that these quantum anomalies are in fact glitches in the matrix, subtle hints that we are living within a carefully constructed digital reality? While we don't yet have definitive answers, the mysteries of the quantum realm continue to fuel speculation and provide fertile ground for exploring the simulation hypothesis. While we don't yet have definitive answers, the mysteries of the quantum realm continue to fuel speculation and provide fertile ground for exploring the simulation hypothesis. As we delve deeper into these quantum mysteries, we may one day uncover the true nature of our reality.